Hi everyone, welcome back to this video on cryptocurrency, Bitcoin relay networks. While the Bitcoin P2P network serves the general needs of a broad variety of node types, it exhibits too high network latency for the specialized needs of Bitcoin mining nodes. Bitcoin miners are engaged in a time-sensitive competition to solve the proof of work problem and extend the blockchain. While participating in this competition, Bitcoin miners must minimize the time between the propagation of a winning block and the beginning of the next round of competition. In mining, network latency is directly related to profit margin. A Bitcoin relay network is a network that attempts to minimize the latency in the transmission of blocks between miners. The original Bitcoin relay network was created by core developer Matt Corallo in 2015 to enable fast synchronization of blocks between miners with very low latency. The network consisted of several specialized nodes hosted on the Amazon Web Services infrastructure around the world and served to connect the majority of miners and mining pools. The original Bitcoin relay network was replaced in 2016 with the introduction of the fast internet Bitcoin relay engine, or Fiber, also created by core developer Matt Corallo. Fiber is a UDP based network relay that relays blocks within the network of nodes. Fiber implements compact block optimization to further reduce the amount of data transmitted and the network latency. Another relay network still in the proposal phase is Falcon. Based on research at Cornell University, Falcon uses cut-through routing instead of store and forward to reduce latency and propagating parts of blocks as they are received rather than waiting until a complete block is received. Relay networks are not replacements of Bitcoin's P2P network. Instead, they are overlay networks that provide additional connectivity between nodes with specialized needs. Like freeways are not replacements for rural roads, but rather shortcuts between 2 points with heavy traffic. You still need small roads to connect to the freeways. Network discovery. When a new node boots up, it must discover other Bitcoin nodes on the network in order to participate. To start this process, a new node must discover at least one existing node on the network to connect to it. The geographic location of other nodes is irrelevant. The Bitcoin network topology is not geographically defined. Therefore, any existing Bitcoin nodes can be selected at random. To connect to a known peer, nodes establish a TCP connection, usually to port 8333. The port generally as the one used by Bitcoin, or an alternative port if one is provided. Upon establishing a connection, the node will start a handshake. See figure 8.4 by transmitting a version message which contains basic identifying information including N version, the Bitcoin P2P protocol version of, the N version, the Bitcoin P2P protocol version the client speaks, N local services, a list of local services supported by the node, currently just node network, N time, the current time, ADDRU, the IP address of the remote node as seen from this node, ADDRME, the IP address of the local node as discovered by the local node, sub-server, a sub-version showing the type of software running on this node, e.g. Satoshi, as 0.9.2.1 / best height. The blocks the block height of this node's blockchain. This version message is always the first message sent by any peer to another peer. The local peer receiving a version message will examine the remote peer's reported end version and decide if the remote peer is compatible. If the remote peer is compatible, the local peer will acknowledge the version message and establish a connection by sending a VERAC. How does a new node find peers? The first method is to query DNS using a number of DNS seeds, which are DNS servers that provide a list of addresses of Bitcoin nodes. Some of the DNS seeds provide a static list of IP addresses of stable Bitcoin listening nodes. Some of the DNS seeds are custom implementations of BIND Berkeley Internet Name Daemon that return a random subset from a list of Bitcoin node addresses collected by a crawler or a long-running Bitcoin node. The Bitcoin core client contains the names of 5 different DNS seeds. The diversity of ownership and the diversity of implementation of the different DNS seeds offers a high level of reliability for the initial bootstrapping process. In the Bitcoin core client, the option to use the DNS seed is controlled by the option switch DNS seed set to 1 by default to use the DNS seed. Although a bootstrapping node that knows nothing of the network must be given the IP address of at least one Bitcoin node, after which it can establish connections through further introductions. The command line argument seed node can be used to connect to one node just for introductions, using it as a seed. After the initial seed node is used to form introductions, the client will disconnect from it and use a newly discovered peers. A figure 8.4, the initial handshake between peers. Once one or more connections are established, the new node will send an ADDR message containing its own IP address to its neighbors. The neighbors will in turn forward the ADDR message to their neighbors, ensuring that the newly connected node becomes well known and better connected. Additionally, the newly connected node can get ADDR to the neighbors, asking them to return a list of IP addresses of other peers. That way a node can find peers to connect to and advertise its existence on the network for other nodes to find it. Figure 8.5 shows the address discovery protocol. A node must connect to a few different peers in order to establish diverse paths into the Bitcoin network. Paths are not reliable. Nodes come and go, and so the node must continue to discover new nodes as it loses old connections, as well as assist other nodes when they bootstrap. Only the connection is needed to bootstrap, because the first node can offer introductions to its peer nodes, and these peers can offer further introductions. It's also unnecessary and wasteful of network resources to connect more than a handful of nodes. After bootstrapping, a node will remember its most recent successful peer connections, so that if it is rebooted, it can quickly re-establish connections with its former peer network. If none of the former peers respond to its connection request, the node can use the seed nodes to bootstrap again. On a node running the Bitcoin core client, you can see the list peer connections with the command get peer info. So here you can see, here's the output from that command. to override the automatic management of peers and to specify a list of IP addresses, users can provide the option connect IP address and specify one or more IP addresses. If this option is used, the node will only connect to the selected IP address instead of discovering and maintaining a peer connections automatically. If there is no traffic on a connection, nodes will periodically send a message to maintain the connection. If a node has not yet communicated on a connection for more than 90 minutes, it is assumed to be disconnected and a new peer will be sought. Thus, the network dynamically adjusts to transient nodes and network problems and can organically grow and shrink as needed without any central control. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.